Ukmt IMC 2016. Let's start from number 11. So number 11, this net, okay, so this is the solid and this is the net. So rhombicuboktahedron, okay. So face mark P is placed face down on a table, which face will be facing up. So this is it is asking about what is the opposite of P. So for example, if P is here, that letter should be next to, not next to, somewhere there. So let's figure it out how we can find. So no need to think about whether it is facing down or up or something. Wherever it is, the opposite is always the opposite. So when P is here, so at this moment, those are the net of these lateral faces. And we have 1, 2, 3, 4, 5, 6, 7, 8. So the opposite will be P is here, 1, 2, 3. D is here, 1, 2, 3. So the opposite of P, there will be D. Sum of two numbers A and B is 7. And difference is 2 when A is larger than B. What is the value of A times B? So A equals 9 over 2 and B equals 5 over 2. So when we multiply them together, 45 over 4, which is 11, and 1 over 4. Number 13. This is heptagon. Each of the line has 3 circles. Okay. So one number from 8 to 14 now is there. So we will distribute from 1 to 7 to the remaining circles, and total numbers in each of the line to be same. Okay. So for example, if we put any number here, this will be used to add here and here. So this will be will attempt to be calculated twice, while those numbers is just used once. So let's say let's make this the sum of this one line S. Then if we make 7S, let's say 7S will make it whatever it is from 1 to 7, they are using twice. So from 1 to 7, this will be used twice, while from 8 to 14 is using once, like this. So this is 7S. So from 1 to 7, 1 plus 2 plus 7, 7 plus 6 plus 1, when we add them all 8. So we have 7 times 8, but this has I added them twice, so I need to make them divide by 2. So 28. So this is 56 plus, from 8 to 14 the same, 8, 9, 14, 14, 13, 8, all of them 22. So we have a 7 of 22, but this, again, we added it twice, so over 2, so 77. So 6S is 56 plus 77. So when I divide by 7, 8 plus 11, which is 19. And number 14. Taek-wen has the same number of brothers and she has sisters. So Taek-wen is maybe a girl. So brothers X, sisters X. So in this family, let's say, as a children, the boys and girls, boys, x-boys, and x plus 1 girls in the family. So each of her brothers, so brothers has brothers, which of the number of x minus 1 brothers. So x minus 1 is 50% more sisters than brother. So brothers, when we multiply by 1.5, this becomes 2 sisters. So 1.5 x minus 1.5, x plus 1, 0.5, x becomes a 2.5, x equals 5. So in this family, we have 5 boys and 6 girls. So altogether, 11 children. Number 15. Circle has radius in 1 centimeter. So this is 1 centimeter. This squares goes to, let's say this is x, then this will be 2x. So by the Pythagorean theorem, x squared plus 2x squared becomes 1 squared. So 5x squared becomes 1, x squared is 1 over 5. We are looking for the area of the squares. So 2x squared is the area, which is 4x squared, and 4 times 1 over 5. So 4 over 5. Number 16. How many of the following positive integers are divisible by 24? Number 24 as a prime factors, it can be expressed like 3 of 2's times 1, 3. So if those are the multiple of 24, it should have at least 3 2's and 1 3's. But all these 3 has only 2 2's. So it cannot be the multiple of 24. And we have this one only 3 2's and 1 3's. It includes. So now we have only one of the integer who is divisible by 24. Number 17. This shape 2 concentric circle annulus. Ready 2 and 14. So maybe this is 2 and this is 14. They should circle divide the area of into 2 equal areas. Oh, okay. So let's say this is R. Then let me call here the outer ring. Let me call it 1. And the inner ring, call it 2. So the area of the 1, shaded area of 1, is the largest circle area, which is pi 14 squares minus pi r squared. And number 2, pi r squared minus pi 2 squared. So both of them should be same. So 14 squared pi minus pi r squared becomes pi r squared minus 4 pi. So 14 is 196 pi plus 4 pi becomes 2 pi r squared. So let's cancel out pi's. And this is 200 over 2 becomes r squared. So r is radius is 10. Number 18. Sum of the areas of the squares on the side of a right-angled isosceles triangle. So this one maybe x square root 2x. And it has squares like this. So this is x squared, this is 2x squared. So 4x squared becomes 72. So x squared is 1/8. So what is the area of the triangle? So triangle area is half of x squared. Therefore, it's 9. Number 19. A list of positive integers has median of 8, mode of 9, mean of 10. So smallest possible number of integers in the list. So number of integers. Let's say when median is 8, if there is odd number of integers in the list, then 8 should be in the center. But if it is not in the center, then we can make like 7 and 9 in the center to make median 8, let's say. So let's think about 8 is in the center or 7 and 9 is in the center. Anyway, whatever it is, we need to have at least 2 9s here. I cannot have 8s here because 9 is mode. So maybe 7 and 6. And maybe 5 one more because I need to add another number to make the mean of 10. Now this is 15, 14, 44 plus x over 1, 2, 3, 4, 5, 6, 7 becomes 10. So anyway, there will be the number. So this is we need 7 numbers here. So this is a 7. Let's say in this case we have 7, 9, 9, and this should be the center. So we need at least one more number on the left side, maybe 6. But to have here, we need another number here. So 5, 6, 7. Actually, those numbers doesn't need to be fixed. I mean, if at least it is the different numbers because of mode, then any number can be. So in this case, here also there will be any numbers there. So 5, 6, 7, 9, 9, x over 6 becomes 10. Anyway, there will be the number. So smallest possible number of integers. I think this will be the smallest possible numbers. Because 9 cannot come to the left. Number 20. 2 semicircles are drawn on rectangle as shown, 8 and 10. So this is 5, and this is 5, and this is 4. So because this is isosceles triangle, when isosceles triangle has this perpendicular line, then it's bisect. Or bisect is perpendicular. So from the Pythagorean theorem, we can tell this should be 3, and this also is 3. So width of this overlapped area of the overlapped region is 6. Number 21. Regular octagon. Ratio of the area of the shaded trapezium to the area of the whole octagon. Okay. Because this is octagon and we have 8 external angles, the sum of external angles for this polygon always is 360 over 8. So now we can say this is 45. Here is 45. So let's say if we make it, if we draw a line like this also 45. This is 45. So let's call this x and x. Then this will be square root 2x. Then this is a regular octagon, so this is also square root 2x. So here is square root 2x and square root 2x. So the whole area is this and this. This and this together is x squared. But we have 2x squared plus this and this and this are same. Square root of 2x squared, but we have 4. Square root of 2x squared plus the center is 2x squared. So this is the whole area. And the shaded area is x squared, but we have 2. No, I mean half x squared, so we have 2, so it is x squared. Plus square root of 2x squared. So now x squared 1 plus square root of 2, 2, 4, x squared 1 plus square root of 2. Oh, okay. So this becomes 1 to 4. Number 22. Particular group of people, some always tell the truth, rest always lie. And there are 2016 people in the group. Sitting in a circle, each person in the group says, both of the person on my left and right side are liars. What is the difference between the largest and smallest number of people who could telling the truth? Let's start at one person who is telling the truth. So this person is telling the truth. And this person says, both the person, people are liars. So this is true, both liar. And this liar is telling also same thing. Both people are liars. But this is the lying, so this should be truth and truth. And truth should be make it lie and lie, and truth. Something like that. So half of them are liar and half of them are telling the truth. So the difference should be 0. But the strange thing is, the question is asking about largest and smallest number of people. Because for me, I have only one case of this. So there's no such a case to compare to make larger or smaller numbers. Let me read the question once more. So now at this moment we have 0. Tell the truth, always right. Always truth, always right. Lying. Okay, I got it. Because this is both. When both is not true, it doesn't mean none of them. When both is not true, sometimes it also true when one lie, one truth. So let's start again. Truth, lie. And this person still lie, even she has one truth, one people who is telling the truth, and one people lying. This makes this person still telling lies. And this person is telling lie, one truth. Truth, lie, of course, because this should be both liar. So truth is all of them, like 2 should be telling the lie, like liar. But for lying, 2 both telling the truth, or only one is telling the truth. So this lie, again lie, truth, lie. Okay. So this is the case. So the previous case was half and half. Half people were lying, half people were telling the truth. So the difference between them was 0, which is not a lot. But here, okay, so we have two cases telling the truth, truth, lie, lie, truth, lie, truth. This was the first case and the second case was there. So in this case, telling the truth is 1/3 of total people. So 672. And the second case, which was my first case, was half of people telling the truth. So between two, there is a difference of 336. Yeah, largest and smallest number of people it says, but actually we have only two cases I can say, because we can start from the person who is telling the truth. If we start from the person who is telling lie, then we can start truth to truth or truth one lie, something like that. It is the same. So number 23. So maybe I was confused. I thought that this is asking about the difference between the number of people who is telling lie and telling the truth. That's why I said that the answer was 0. But I should find other cases because this is only asking about the number of people who is telling the truth. So number 23. This is penny. Design for equal arcs, quarter of a circle, so like this. Let's say. And radius of the small circle in centimeters. This is 2. Then this should be square root of 2. And this is square root of 2. And this is 1. This is 1. So if this is 1, then this is 1. And this part should be square root of 2 minus 1. So now we need to find here. So 1 minus square root of 2 minus 1 should be 1 minus square root of 2 plus 1. So 2 minus square root of 2. Every day, Amy goes up an escalator on her journey to work, stands still. 60 seconds to travel. Okay, so time with escalator was 60 seconds. From the bottom to the top. One day she need to walk a bit and it took her 90 seconds. So walking time was 90 seconds. How many seconds? So this was like only escalator and only walking. How many seconds would it take her to... So escalator plus walking, like this. All this case anyway, we are using the same escalator which has the same distance of the journey. So we are sharing the distance. So we know this triangle, distance, speed, time. So now we need to know the time. So we need to find the distance over speed of E plus W. And E plus W should be distance of speed E plus speed W, because they are moving on the same side, so they are helping each other. So the speeding up. So let's find S speed of escalator is distance over time. So distance is the same d. Time was 60. And speed of walking, distance is same. Time is 90. So d over 60 plus d over 90. So d 180, 3d plus 2d. So d times 5d times 180. So this is 36. Number 25. This is the tilting pattern. Uses two types of tile. Hexagon equilateral triangles, the length of each side of the equilateral triangles equal to half of the length of each side of the hexagon. Large number of tiles used to cover a floor. Okay, so this is like repeating. And each one hexagon has like 6 triangles. But each triangle has also 3 hexagons. So let's say simply, each triangle is sharing like 1/3 to each the hexagon. We can say simply like that. Then let's say if this triangle has this area of S, because this is the half, and we know the hexagon has 6 equilateral triangles, and this has the length of twice, which has quadruple the area. So this is 4S. So one hexagon is 24S, and this has the 1/3 of S, 6 over 1/3 of S. So this is just a simple calculation. So all of these, 24S plus 6 over 1/3 S is the total. Out of that, we have shaded black, 6 times 1/3 of S. 26S and 2S and 1 over 13. So that's it.